Bismillahirrahmanirrahim and Assalamu alaikum, my dear students. I welcome you all to the lecture number 7 of Electric Circuit Analysis 1. Today we are going to study source transformation. Transformation means to change the form of something, to transform from one form to the other form. And sources, as you know, in electric circuit analysis we have two type of sources. We have current source and voltage source. So now we will study the mechanism how to change a voltage source into a current source and vice versa. This means that sometimes we might be having our current source in parallel to a resistor, and that can be changed to a voltage source in series with a resistor. And the other way around, whenever we have a voltage source in series with a resistor between two terminals AB, the same thing can be replaced by a current source in parallel to a resistor between the same terminals AB. Please keep this in mind, that the polarity of the voltage source and the arrowhead of the current source are pointing towards the same direction. This is how we simplify the circuits, and this is the methodology is by substituting the voltage source by the current source or the current source by the voltage source, vice versa. However, the resistor value remains the same while we are performing the transformation of these independent sources. So we'll now proceed with an example, which is a practice problem number 4.2, which is 4.20 on page number 164. So here we have a electric circuit in which we have a 3 ampere current source, this 10 ohm resistor, this resistor in series with a voltage source, this resistor in series with a voltage source. So we have to use source transformation to reduce the circuit in the figure below, and the reduction must be done till the point that we are only left with one single voltage source that in series with a single resistor. So this entire circuit has to be transformed into one voltage source in series with a resistor. And right now I can see I have 1, 2, 3 sources and 1, 2, 3 resistors. So this all has to be minimized and simplified to one voltage source and one resistor. So we can see that we have two voltage sources in series with resistances. So first of all, what we'll do is, as by source transformation theorem, we'll change this into the equivalent current source in parallel to the resistor, and this also into the equivalent current source in parallel to the resistance, the same resistance value. So I'll show you, like 20 ohm in series with 12 volt is replaced by the V is equal to IR and I is equal to V by R by Ohm's law. This is how I get the new current value, and the same resistance goes into parallel to the transformed current value. So similarly, when we have the 40 ohm in series with the 16 volt, this is how I get the value of the new current source. I is equal to V over R. V is this voltage source value, R is this 40 ohm, and this yields 0.4 ampere current. And please see that the polarity plus is in conformance with the arrowhead, and the 40 ohm resistor goes into parallel. So now what we'll do is we'll substitute these two transformed into the original circuit, and this is what I get: 0.6 ampere in parallel to 20 ampere, 0.4 ampere in parallel to the 40 ohm. Now you can see that we have three current sources. One is this, one is this, one is this. So, and these are all between the same nodes. This is all same node, this is all same node. So we can sum up these, and what I did is I did it stepwise. First of all, I summed up these and what I get is 0.4 plus 0.6 plus 3. So this I equivalent turns into 4 ampere, and you can see that all are pointing upward. So the final arrowhead will be also pointing upward, and the resultant circuit will be 4 ampere circuit. So now I see that I have a resistance 10 ohm, a resistance 20 ohm, and a resistance 40 ohm. These are all in parallel to each other. So what we'll do is we'll find the R equivalent, resultant equivalent equivalent resistance of these these three resistors. This is the formula that we use while the resistances are in parallel, and this is how by simple arithmetic I find that the R equivalent value is 5.714 ohm. So now you can see that I'm left with one I equivalent, that is the current source, in parallel with this R equivalent, which is 5.714. But I was asked to simplify this circuit into one voltage source and in series with one resistance. So I can simply use the source transformation theorem, and V is equal to IR. So I is 4 ampere multiplied by 5.714 yields into the voltage source 18.3 volt, and the same resistance is in series. So this is what I get as a summarization. Now I proceed on to the problem number 4.22 of exercise chapter number 4. It is also related to the same topic, that is source transformation, and you can see that we have to find the current I by using source transformation. So I have to simplify this circuit and find the current I that flows through 4 ohm resistance, but the theorem that I have, the methodologies that I have to use is the source transformation theorem. So what I do is, in the given circuit, you can see that I have a current value 2 ampere in parallel to the 5 ohm resistance. So I can transform this source, and moreover I have one source transformation over here, so I can do transformation of this circuit, and what I get is the 2 ohm is in parallel to the 5 ohm resistance. So please recall that the arrowhead should be in conformance with the polarity of the resultant voltage source. So that's why over here the arrowhead is downward, that's why the polarity plus sign is towards the ground side. And V is equal to IR. By this method I can find the new voltage value. 5 ohm is the resistance that will be transformed in series with the new voltage source, and on this side I can see that I have 10 ohm in series with voltage, so I can transform into a current value, and this is how I get the transformation. Then now the plus sign is here, so the arrow will point towards the upward direction. This 10 ohm resistance that was in series is now transformed to the parallel position. So this is how I get these two transformation, and now I am substitute there is it in the original circuit, and this is what I get the resultant circuit. This is the new transformation, and this is the new transformation. So now in the new transformation you can see that I have these two resistances that are in series, and I don't have to find any current or voltage across this. So I can simplify the circuit by simply summing up them. They are in series, so I can find the R equivalent by simply adding these two values. These sum up to 10 ohm, and I find the equivalent circuit, the more simplified circuit, as this. Now I have to find this I, but what I'll do is I can summarize or simplify the circuit by doing source transformation again over here. So what I do is I again source transform this circuit. This is a voltage source in series with a resistance, so I can change into a current source. Now the plus polarity is downward, so the arrowhead will also be, the current arrowhead will be in the downward direction. I is equal to V by R. V is 10, the R resistance value is also 10, so the resultant current value is 1 ampere. The same 10 ohm resistance goes into parallel. And the rest of the circuit is the same. We are not going to change it. Now you can see that I can easily find the. Now you can see that in the resultant circuit I have this 10 ohm resistor and this 10 ohm, and these are of no use to me, so I can sum up them by taking a parallel combination of this. R equivalent of this 10 ohm, this 10 ohm is in parallel to this 10 ohm, and by finding it the R equivalent, I get to know that the R equivalent is 5 ohm. So I can simply replace these 10 ohm by a 5 ohm, and moreover I have two current sources. One is this 1 ampere which is heading towards the downward direction, and this 2 ampere current which is towards the upward direction. So I can also take the I equivalent of this, and what I get is 2 ampere which is positive, and 1 ampere because it is in the opposite direction. So what I get is 1 ampere in the upward direction, and I replace this by the new circuit that I get is this is the new circuit that I get. Now what we are left with this simplified circuit. I cannot further simplify it, so what I do is I find the current I by using current divider rule. This 1 ampere current is being divided into two paths, this 4 ohm path and this 5 ohm path. Since I have to find this current through 4 ohm path, So by current divider equation, you put the opposite resistance in the numerator, sum of all then in the denominator, and multiply it by the applied current source. Applied current source is 1 ohm, opposite is 5, and the sum of these two resistors is 4 plus 5. So this is how I get the current value going through this path, and I use source transformation to simplify or understand this circuit. So now we'll move on to the next problem, which is problem number 4.23 of your book. In this we have to use source transformation to find the current through this 8 ohm resistor and the power absorbed across this resistor. So, and I have to use source transformation. Now you can see I have a network over here. The 3 ampere current is in parallel to this 10 ohm. This over here I also have circuit which can be transformed. So what I do is I first of all transform this 15 ohm source, this combination, this voltage source and this resistance, and when I transform it between the same terminals A and B, it changes into 3 ohm resistor, and in parallel with the current source, the new current source is value is found by I is equal to V over R. 15 by 3 is 5 ampere, and the same 3 ohm resistance goes in parallel with the transformed voltage source. Now the circuit becomes, this is the same circuit. The 8 ohm is the resistance across which I have to find the current and power absorbed, and this is the resultant circuit that has been replaced. Now I can easily take the parallel of these two resistance so that I can simplify the circuit. I simplify the circuit. The R equivalent of 6 ohm in parallel to 3 ohm yields to 2 ohm. And now I replace the original circuit, this 6 and 3 by 2 ohm, and the remaining circuit is the same. Now you can see that I can transform this 3 ampere current source and in parallel to this 10 ohm into a voltage source. So what I do is I find the transformation and I replace this 3 ohm 10 ohm into the original circuit. This is how I get the transformation. And over here the transform circuit is now shown as this. Over here I also transform this thing, and now this has been transformed, putting this transformation in the original circuit and this transformation into the original circuit. I get this. Now I apply, I have to find the current across this 8 ohm resistance. I can simply apply a mesh or a KVL across it, and by this I can find the current flowing through the loop. So V gain is equal to V loss. 30 volt is the gain, 10 volt is the loss. I simply put a KVL equation, apply Kirchhoff voltage law, and this 30, this 10 goes here. The current, same current I flows through all the 3 resistance, 10 ohm, 8 ohm and 2 ohm. I sum up the similar values. This is how I do this. This gets to 20. This also comes up to 20. I is equal to 20 volt by 20 ohm. What I get is the current flowing through the 8 ohm resistance is 1 ampere. And by power absorb formula, you know that P is equal to VI or I square R. I is 1 ampere, so I put the value of 1 ampere current, and R 8 ohm. So this is how I get is the power absorbed by the 8 ohm resistance is 8 watt. So this is how we get to know the source transformation theorem. I wish you best of luck. Kindly solve exercise problem, chapter problems, and have a better understanding of source transformation. In case you have any problem, please do let me know. Take care. Allah Hafiz.